Friction. Friction is a force that tends to oppose the motion of two bodies in contact. For a body to just begin to slide over another, this force must be overcome. So we have two types of friction. We have the static or limiting friction. It is the type of friction that exists between two surfaces in contact and they are at rest. There's no relative motion between the two bodies. And we have the second one, which is the dynamic friction or kinetic friction. The dynamic or kinetic friction is the frictional force that exists between two surfaces in contact but what are in motion. For instance, a moving car, a moving vehicle, and what have you. So the frictional force is given by the symbol mu r, where mu stands for coefficient of friction, r stands for normal reactional force. We'll see where we get this formula from later on. So as such, we can say that our coefficient of friction is equal to F over R. So if the normal reactional force is equal to weight, and we all know that weight is equal to mg, then we can write this formula to become force being mass times acceleration divided by weight, mg. We're going to have the coefficient of friction to be acceleration divided by acceleration due to gravity. So that is that. Now, I usually discuss friction or express friction under 5 main headings. Yes, there are 5 scenarios in which frictional force can occur. So I've drew 2 out of the 5 cases. So let's quickly take a look at these 2. Maybe in the next video, we'll talk about the remaining 3. So for case 1, is when you have a horizontal system such that the object is placed without an inclination. It is placed on the flat surface, on the horizontal surface, as shown in the board here. So in this case, this mass has its center here, so therefore the weight, the gravity will act at the center of mass, and we have the weight acting through in this direction. Our weight equal to mg. Now there's going to be a force that tries to balance this weight, known as what? The normal reactional force, R. So as such, our normal reaction force will act in line with the weight to balance this object to make it at rest. So the frictional force in this case now exists between this surface that are in contact, that is this box, and this plane, for instance a floor. Now the frictional force always changes direction with respect to the direction of force applied to it. If I apply a force in this direction to move this crate towards this direction, let's say a force F applied in this direction, then frictional force will oppose this force in this direction to move here. This is our frictional force, Fr. So as such, now we see that the frictional force what will be this way. So technically now our frictional force will be equal to the coefficient of friction multiplied by the normal reactional force. So which is the case that we talked about here. So if here we are having our normal reactional force to be equal to weight, as we have said here. So if R equal to weight as shown here, we see that our frictional force will be coefficient of friction times what? Mass times acceleration due to gravity. Also, if this mass, this body here, has no motion, there's no motion as stated in the static friction. There's no motion, everything is at rest. We can say that the frictional force is equivalent to what? The force acting on it. That is, the force is not enough to move it. So that is why it is still at rest. So therefore, our Fr equal to what? The force applied, and our force applied is mass times acceleration. So equating the two of them, mass times acceleration equal to coefficient of friction times mass times acceleration to gravity, will now become coefficient of friction to be acceleration all over acceleration due to gravity after striking the two masses out. So this is how we come about this guy here in the first stage. So the next thing we would like to take a look at is when we have an inclined plane. When we have an inclined plane in this case too, we have a mass resting on a plane inclined at an angle theta to the horizontal. So in this case, we know that our normal will act to the plane this way. This is our normal line passing through this plane in this manner. So we can see that this is our normal reactional force, R. But the weight of this object is concentrated here, so it will act downward like this. The weight will come this way. So the weight will not change just because the normal to the plane has changed. The weight will still act downward. So if the weight is acting in this manner, then there is an angle here, theta. So by analogy, theta here is equal to what? theta here. That is, the angle here is equal to the angle here, because this is a normal to this line and this is a horizontal. So this line is acting as a horizontal to this normal too. So from here now, if we wish to express this weight to become our normal rational force, we have to what? Resolute this force to this part. That is, we're going to close this angle to become what? This line. So by closing this angle, by moving this line towards this side, we find the relationship between this line and this line. So if here is our theta, then this line, that there's a line, arbitrary line down here, becomes our what? Our opposite. Here becomes our hypotenuse, and here becomes our adjacent. Therefore, here closing theta, now we have this line to be W cosine of theta. So we cannot resolve it in just one direction. We have to resolve it in the two directions. So we assume that there's another horizontal line here, so that we resolve it to this side. We have this place to become what? W sine of theta. This makes sense because whenever you hold, let's say, this marker or an object in an inclined plane without any force, once you drop it, if the plane is not rough enough, you see that the object begins to what? Slide down the plane. What is pulling it down? It is nothing but what? The force due to the weight and the inclination of the angle, which is not present in the first case. So as such, now we see that this weight, now the force of weight, we try to pull this object down. Then as this is happening, based on the initial explanation, frictional force will not occur unless there's a force trying to move it. So now there's a force trying to pull this guy down. So frictional force will tend to what? Oppose this motion. Frictional force will oppose it. So if the frictional force is enough to stop this from moving, then our frictional force will be equal to the force of weight, that is W sine theta. But if it is not enough, this object will still manage to slide down the plane. So that means that the total force required to stop it from sliding is you taking frictional force from this one, because the frictional force has reduced this. So the net force here now, our force here will be what? These two forces. One is acting in the opposite direction, the other is what? That's why we said this minus this will give us the resulting force that is still making it to slide down the plane. So technically in case 2, our normal rational force becomes W cosine of theta. That is, this is the normal rational force in this case. So our frictional force now, F equal to mu R, becomes mu W cosine of theta. So if you want to extend it, you can say that this is what? Our coefficient of friction. Our weight is the mass. Okay, there's a mass here. M times what? G cosine of theta. So this is the frictional force in this case, which is quite different from this one. Yes, this is quite different. So, and yes, there are questions under this that can be what? Technical. The question that you can have from this case too is that you can be asked to find the force that is required to stop this object from moving. If you have to find the force to stop that is required to stop it from moving, all you do is take the frictional force from this one, and you have the resultant force that will be enough to stop this object from sliding down the plane. Another case is that you can be given an extra force pulling it up the plane. Yes. So maybe we talk about that in another case when we introduce the next case. So if you have to find the force that will be able to stop it from moving, the force becomes what? The force of weight minus frictional force, which is mu W cos theta. So that is that. So this is the force that will stop it. Unless you are asked to do so, you don't have to do it. Maybe when we start applying this to questions, you understand better.